Welcome to a new session. This time, solid code in C#, a small introduction into the solid principle and how it looks like in C#. What is solid? Copied from Wikipedia. It's in responsibility, open-close principle, list curve substitution principle, interface separation principle, dependency inversion principle. So a set of such principles together to assure good solid code, especially as written for agile development or adaptive software development. Single responsibility I want to show more in detail. It mainly says one class, one responsibility. I have an example. Getting data from a database, for example, filtering data, validating data, formatting data, displaying data. In older code styles, or perhaps also in some more new code, it could happen that we have one very big class represented by this byte circle, and a lot of such functionalities, perhaps a method, get data, filter data, at least it's separated in multiple methods, but all connected to one another. Perhaps one method is very large, doing a lot of stuff. And if you want to improve the code quality, you would do single responsibility by putting out multiple classes. So here you would now have only the class for data access, class only for filtering, for displaying. Another principle is the interface segregation principle I want to explain. It says one interface, one purpose, but one class can have also multiple interfaces. Here, for example, could be like the data access class. I have iRead and iWrite. However, I call it just as an example. So you could, for another component, say it should only read data. So the whole code just only uses the iRead interface. The other class or the other component only writes data and does not need to know any of the data to read. So it just uses the iWrite interface. With this, it's easier to debug also, or to prevent bugs, because you never execute or call a method which is not intended, because the interfaces are so small that they only provide a very few methods. And then, very important, and what I mainly will show in the example code, dependency inversion principle. I would, in easy sentence, say constructor of classes gets dependent items objects. Let's see how it was before. We have, for example, now one component, one view, or some other logic. We want a logger to log data, what was going on, are there any errors, debugging, logging, information, whatever, and a sorting. We would have different responsibilities, of course. Logging separated from sorting, everything is fine, but we create all in the same classes. Dependency inversion control principle says it must come from the outside. So no more new is used inside the constructor, but it's passed on from outside. So the one item or the one class who needs this component with this constructor is responsible for providing a logger and a sorter. And perhaps this component also is requiring some components, so it's also requesting such items from outside. Reason for this is, for example, you can replace easier. Here, if it's all in the constructor, it's hidden from outside. You need to know what's in the constructor. You need to know the components. If it's from outside, you see it directly, And the caller of this constructor can of course exchange. Say I have a file-based logger, a network-based logger, email logger, whatever, and can easily replace the instances. Let's look how it goes via code. Empty project, we start here from scratch. My idea is a task-based program. So we will first have a new class, like my task repository. Also, what the solid principle says, never use direct instances, always or direct classes, always program against interfaces. So later we will also create an iTask repository interface. But for now, what do we want? We want, for example, public task or public enumerable of task. Get all tasks. Task probably not a good way. Live task. Otherwise, it's with the task parallel library conflicts. So I create a class, get all. And for debugging purpose or to make sure it works, I will just return some instances. So new live task title equals more sport. Could be, for example, application for New Year's and status of done equals false. Okay. Yes. So now we can do more, like learning new language. That's for the first thing, that's all. Now, as I told, we need to make sure that we always code against interfaces. Therefore, we can use, let me see. Make it easier. Just extract this way. So, come on. Okay. Now, I would also like to have a filter mechanism to filter all not yet achieved tasks. So I just create filter to do tasks. Should work. And of course, this will return an enumerable of how is this called? Live task. Still to do tasks, and this of course needs also also as input the other tasks. The input, and as everyone can imagine, this is just a small link query where, on using link x dot done is not done, easy. So now single responsibility is fulfilled. Okay, we also need to create I filter to do tasks. Come on, so I filter to do tasks. So okay, good. How can we use this now? I could, for example, write in my main application, so I task repository, requesting my source. This of course then use the real task repository instance. Then I have my I filter to do task as my main filter. I can create this, of course. Filter to do tasks. And execute such operation. Of live task. Equals filter dot still to do task from my source dot get all tasks. And of course I could return the content of such filter task, for example. Let's just next join. The separator is just a comma, and then filter tasks dot select. Using system link should always be added. X dot title. And if I run the application, more sport, learning new language. So it works. But now let's make it a bit more interesting. I want to extend it with logging. So first, a new responsibility. I cannot add logging to the repository or to the filter class, because they already have their own responsibility. So I create my logger. What does it have? Public void log string message. And I will make it interesting. I make one read-only string builder as my main content provider, or the content of all log entries. So, therefore, content append line. Perhaps I just make also data now plus, and then the message to add. And of course, for getting the result at the end, I need another method to get me the string builder content. So get all entries return content. Okay. Here, for example, principle of the interface segregation would work in a way I could make one interface for just logging and one interface for getting the content, because no one will really need this during the run, for example. Okay, usually you would directly write to a file, so you don't have such get all entries method, but you could have another method for configuring a logger. Do you need to configure a logger in your application logic? No, you will probably only need in your config dialog the possibility. So interface segregation can help you to build really solid code in a way that only intended use is possible. But to make it short, or to get straightforward application, I just put both method in one interface. In this case, it would be not following completely the solid principle. So, how to use now the logger? I want logger in, for example, the repository. I want to log if get all task was called. For example, let's say you have a database and you want to log every access. And then perhaps you see, oh, it was permitted or not permitted, you have a security problem. So logging in a repository could be very useful. What I do, I will just private I logger log. Again, remember, we program against interfaces, not implementations. Here, in such small example, I could also write just private logger and not using the interface. But this would not follow the solid principle. And then make my constructor. Would this follow the solid principle? Not really. We remember dependency inversion principle, and exactly this we will do. So I use iLogger as input parameter. Now I can store my instance, can add here log entry, returning one item, and then we can do this the second time, or here even no more items. No more items. What will now happen? Here we will have an error. iLogger logger equals new logger. Now, as the caller of the constructor or the object or the component which requires the task repository, I'm now responsible for creating the required components. So I'm now, as class program method main, responsible for creating the logger. The same thing for the filter to do tasks. I will do the same. Private I logger as logger. Public filter to do task. I logger. Logger equals logger. And also, what I also always just make it read only. It should only really come from the constructor, set it one time, and that's it. So here I make it a bit more interesting. Not just logging that it was called, but let's make this to a list. Dot to list logger filtering items, and then result dot count, and return the result. Switching back to the program, now I also need the logger here. And at the end I can like, let's say an empty line, and so right line, and then the logger dot get all entries. So same logic, we just inserted one dependency from outside, the logger, we still executing this filtering, we write down the results, and then also the logger entries. Returning one item, no more items, filtering items 2. Great, so it works. When you follow this, you already do a lot solid code, but you will see more dependencies come. For example, if we don't want this static void main, we want a formatter class. Again, this would be single responsibility, but this formatter, for example, would need for perhaps the iTask repository or the filter. So the caller now of this formatter class would need more and more dependencies. The logger, the task repository, the filter to do task, and more. What can we do? Shall we always make more and more requirements, putting more and more effort in such passing on of constructor parameters? Not really. For this, dependency injection frameworks help. Here in my .NET Core application, I added one NuGet package, the Microsoft extensions dependency injection. But there are many more. There are a lot different dependency injection frameworks like Ninject and more. So, I already prepared one thing called the resolution route. You can call it however you want, but this is like the starting point of my framework. I have made a singleton pattern so that from all of my application I can come to this resolution route instance. This instance itself has a service collection. I make then register service. The register service I will explain later. And at the end I have a service provider. And this provider is then like a dictionary or component which can help me creating all the instances I need. So, but how does this dependency injection framework knows anything about the logger or the task repository or this filter to do task? I need to explain this. So I can make an add transient. It's this one. I task repository to wait, what was this? Add transient. Oh, sorry, it's this way. My fault. Task repository. Then I can do the same for I filter to-do task and then filter to-do task. So I explained, if someone wants the iTask repository, please give this caller in task repository. Or if someone wants the iFilter to-do task, return an instance of this class. But one thing is missing. I make an add singleton of my iLogger, because what will happen without this line, I will request an iTask repository. It will look, oh, to create a task repository, I need an iLogger. Do I have any configuration for iLogger? No. This will make problem. So here now we have all the information for the Dependency Injection Framework. If I request iTask repository, it will go to this class, will send the constructor is requesting iLogger. The Dependency Injection Framework sees, oh, iLogger in singleton scope, and will return a logger instance. If I request then the iFilter to-do task, it will use this constructor, will see singleton scope, and return the same instance. So I have a lot of options here. I also have add scoped. This is, for example, for web applications, and your scope could be one web request. User goes to your website, the scope starts. Now if an instance is requested, the same will be returned always, as long as the web request is executed. If another user goes to your website, the scope will be different and a new object will be created. So you can make session handling even with a dependency injection framework. Let's go back to our program. This is not more needed. Sorry. So we can use now the resolution root .instance container get service. And then type of iTask repository. We need to cast this. And then the same for the filter to-do task. So iFilter to-do task, iFilter to-do task. So, and here, of course, we can then directly ask for the iLogger to get the instance of the iLogger. Okay, round brackets, one more, yes. That starts, and it's returning except the same content. So this dependency injection framework helped us to get rid of all constructor calls. Only we needed to set up such service collection. We needed to configure this interface to this object, this interface to that object, and we could, even if we have different loggers now, just exchange here. We say, oh, I don't want this memory logger, I now want a file-based logger, or now I want the email logger. I just need to replace this in this configuration, and every other component which requires an iLogger will get our new logger, not more the old one. And also our current code is easier for testing, because now this filter to-do task does not have anything about getting the instances. It's just about filtering. So we could write a unit test testing exactly the still to-do tasks method without concerning building up database connection, getting data, accessing file, or anything else. Single responsibility pattern is also assuring that if we have a task repository, it's all about just the task repository. It does not need to know anything about filtering, or it does not need to know anything about formatting and all this stuff. So also bug fixing. Let's say we have a problem in the filtering. Some unwanted items are shown. Yeah, then go to the filter to do task class. If we have, for example, a logging problem, we go to the logger class. Also, extensibility is now easier. If we need a new filter, we just implement a new class from this iFilter to do tasks. Or perhaps adding new components. We need, of course, adding here more entries in our register services, but we keep the structure and just adding new functionality.